So the slope-intercept form is what?
All
right.
Let's go, Jay.
What's the M?
Slope.
Slope.
So you needed to solve the problem.
The B?
Why not? So it can't be overused.
XY?
Ordered pair.
Ordered pair, yeah.
What else did you use? Yeah, but I didn't know they-
In terms of the graph, what would the XY represent? A coordinate? It could be a solution, depends on what you're looking for, but specifically in the case of the slope-intercept form, it's a point on the line. All right, so if you put it in an x value, it'll give you the y value that goes along with that x value, but only for points that fall on that line. The graph was pretty straightforward, hopefully. Scale-wise, it might have been a little funky, but nothing too crazy. Y-intercept of 4, slope of 2. Now, if you just did something like this, that hurts my feelings. Just know that you can follow the same trend, but in the opposite direction. So, especially if you don't have a ruler. If you don't have a ruler, you want to plot as many points as you can, because if you're freehanding it, we go by the points, not the quality of the line. All right, arrows on the end because the domain is not restricted. All right, so we're not looking at a domain that's in between the two particular values of x. All right, it could go from negative infinity to infinity. By the way, if you wanted to represent the domain of this, just as a refresher, negative infinity to infinity, would that involve parentheses or brackets? Parentheses. All right, and why is that? Because it's infinity. Yeah, infinities, and arrows. Always get parentheses. Okay. So if there's arrows on the end, it's going to some kind of infinity, whether it's positive or negative, it's always going to get parentheses. All right. So the question didn't ask that, but anytime we can review an old topic, as you know from the problem sets, it's probably a good idea to talk about it, right? Okay, so circle the equations that are linear equations. All right, so anything that doesn't have a power higher than 1 is going to be linear. So we got one right meow. We got one right meow. We got one right meow. And finally one right meow. All right, so it looks like we have a total of 5 mirrors. All right, so just as long as you keep track of the number of mirrors, you'll always be fine. All right, so power of 2, power of 3, power of 2, power of 2, so those are all out. The only concern you might have had, or you should have only had, would be, well, these two don't have both x and y. Well, they don't have to, because a line can be horizontal, in which case it's just y equals. It could be vertical, in which case it's only x equals. All right. So if that's the case, then you would lose a variable along the way. All right, and that's perfectly fine. All right. So told you exactly what the answers to the next question would be. A vertical line is x equals some number. All right, number. Usually it's something like x equals a, where a belongs to the set of all real numbers. Well, it's 2-hour delay day. We'll keep it simple. Horizontal line would be y equals some number. All right, the important thing would be that those numbers have to be real. All right. A good working definition for real would be what? Sometimes we define something by what it isn't. Not irrational, but it starts with an I. No, not irrational, but it starts with an I.
Irregular?
Not irregular, wrong course. Good use of the word I. What do we say? I think I heard it. Imaginary, yeah, it's not imaginary. Right, so,
We all
Yeah, irregular verbs, right? So in math, it's really, at this point, either irrational or imaginary. Imaginary is the case where there's a negative under a radical. All right, so those don't appear on the graphs that we create. What slope do you think a quadratic, slope. We'll get to that part. What shape do you think a quadratic equation will make? This is a conjecture, it's just a thought. Like, what do you think? Quadrilateral, so something like this? That would be awesome. I mean, it's a good thought. It's a really good thought. They both involve a quad. All right. Now the issue is the quadratic equations are functions. Functions need to pass the vertical line test. Will this shape pass the vertical line test? No. All right. So that was an example of a quadrilateral, and it doesn't really play out. So any other kind of quadrilateral probably isn't going to work. But it's a good thought. It will start with quad. Why not? All right.
Like if it's a curve, it's a positive, and then if it's like an upside down curve, it's a negative.
Yeah, you're talking about a curve. So you got something like this, something like this. All right. The name for that? A parabola. Yeah. Also known as a U. Yeah, actually, honestly, pretty sure historically that's the correct pronunciation. So it's just, sometimes in the English language we take the ordinary pronunciations of words and we try to make it sound more like flowy, yeah, schedule sounds like it would be fun to say. Yeah, did you check your schedules to see where you're going next? But you only say that when you feel like being silly, right? We say it's schedule, right? But there's a whole population in the world that pronounces it schedule. I can't bring myself to say coupon. It really sucks the soul out of my body to do that. It's like just not. Every time I say it, I said it that one time. I feel like I knocked 7 months off the back end of my life. Like it is actually causing me physical harm to say that. There's things like tomato, where I don't think there's really an argument there. I don't think anybody, or I don't want to say that. It's not a frequent occurrence. When you go into the cafeteria, if one person were to go in there and say, "Oh, I'll have tomatoes on my," they're not saying, "Yeah, so what's going on, dude? Hey, what's going on, bro? Yo, let me get some tomatoes on my burger." No, they're usually saying, "Oh, hello, ladies and gents. Let me have some tomatoes on my
Yeah, I know that.
so it's really more like that. They go the distance with everything.
Orange. It's
So-
orange.
I agree with the orange
It
pronunciation.
was orange and the A-R.
Oh,
Here's the thing, the or part of orange. Now, full disclosure, I pronounced it for the first 35 years of my life as orange because that's how everybody around me pronounced it. But then somebody said, well, it starts off with the word or, doesn't it? Like, all right, fine.